Are there other beings out there, somewhere beyond the stars? Or is Earth the rare cradle of life, a lonely island in a sea of cosmic silence? Tonight, as you dim the lights and let your mind drift among the galaxies, prepare to explore the evidence, the theories, and the mysteries that could change everything we think we know. If you enjoy exploring the unknown and unraveling cosmic mysteries, don't forget to like this video and subscribe to join us on this incredible adventure. But before we get too comfortable, consider this. What if the answer is not out there at all, but right here, hiding in plain sight? What we uncover next might shatter everything you believed about our place in the cosmos. Ready? Let's begin. For as long as humans have looked up at the stars, we've wondered if someone might be looking back. It's a question so deeply woven into the human experience that it appears in the earliest myths, religious texts, and stories told around ancient fires. Are we alone in the universe? Today, that question remains as powerful and as unanswered as ever. But now, we have something the ancients didn't. Science, a question older than civilization. Long before telescopes or satellites, humans imagined the skies were populated by gods, spirits, or otherworldly beings. In ancient Mesopotamia, the heavens were a realm of divine activity. The Greeks speculated about other worlds. Some philosophers like Democritus and Epicurus even suggested the existence of infinite worlds, some possibly inhabited. In medieval Islam, scholars like Al-Farabi debated the philosophical possibility of multiple worlds. Later, during the Renaissance, thinkers like Giordano Bruno famously proposed that stars were other suns with their own planets, possibly teeming with life, a dangerous idea at the time. Across cultures and eras, humanity has asked this question, not just out of curiosity, but because the idea that we are not alone touches on something profound. What is our place in the cosmos? The Copernican blow to human exceptionalism. The journey toward modern astronomy began with a cosmic demotion. In the 16th century, Nicholas Copernicus proposed a heliocentric model, placing the Sun, not Earth, at the center of the solar system. This was more than an astronomical idea. It shattered the illusion that humans held a privileged position in the universe. Since then, every advance in science has reinforced this theme. Earth is one planet among billions. Our star is one of hundreds of billions in the Milky Way. And the Milky Way is just one of perhaps 2 trillion galaxies in the observable universe. These discoveries don't diminish our significance, they reframe it. If life arose on Earth under natural conditions, then surely, under similar conditions, life might arise elsewhere. The question is not just if, but how common life might be. From wonder to science, the question, are we alone, has evolved from a metaphysical speculation into a scientific pursuit. The 20th century marked a turning point. With advances in physics, chemistry, and biology, we began to understand the conditions necessary for life. The discovery of DNA, the mapping of the periodic table, and the understanding of planetary systems laid the foundation for modern astrobiology, the scientific search for life beyond Earth. The advent of space travel gave us new eyes in the sky. The Apollo missions showed us Earth as a pale blue dot, fragile, vibrant, and singular. But was it truly unique? We sent robotic explorers to Mars and spacecraft to the outer planets. We launched radio telescopes to scan the skies for signals and built space-based observatories to detect distant planets. Each mission, each technological leap, brought us closer to understanding our cosmic context. Why this question matters: it's tempting to see the search for extraterrestrial life as merely a scientific curiosity, but it's far more than that. Whether or not we are alone is a question that touches on philosophy, religion, ethics, and identity. If we find life elsewhere, especially intelligent life, how would it affect our religions? Would belief systems collapse or adapt? If we are alone, what responsibilities does that impose on us? To protect life, to preserve Earth, to be stewards of consciousness in a lifeless universe? This question also has practical implications. Understanding the prevalence of life helps us understand how life begins, how resilient it is, and what its future might be. In turn, it might help us answer another critical question: can we survive ourselves? Our place in the narrative. Some scientists believe the universe may be teeming with life, but that most of it is microbial or primitive. Others think intelligent life may be exceedingly rare, or even unique to Earth. Still others wonder if we are already surrounded by life. but simply lack the tools or the perspective to see it. In asking, "Are we alone?" we are also asking, "Who are we? What is life? And what does it mean to be conscious in a vast, ancient, and possibly silent universe?" This is not just a scientific question, it is a human one, and it is the starting point of our journey. Before we can search for life beyond Earth, we have to understand what life actually is. That might seem like a simple question, but it turns out to be surprisingly complex. Defining life isn't as straightforward as it sounds. On Earth, life comes in many forms: humans, trees, bacteria, mushrooms, jellyfish, and countless more. Despite their differences, all living things on Earth share some basic characteristics, and it's these common features that scientists use when searching for life elsewhere. What is life? In science, life is usually defined by a set of criteria. Something is considered alive if it can grow and develop, reproduce, respond to stimuli, maintain homeostasis, a stable internal environment, use energy, evolve over generations. In practice, things get messy. For example, viruses can reproduce and evolve, but only with the help of a host cell. Are they alive? Some scientists say yes, others no. But for the purposes of the search for life beyond Earth, we focus on life as we know it, meaning carbon-based life that uses water and energy to grow, reproduce, and evolve. The ingredients of life. All known life is based on a few essential ingredients. These include 1. Carbon. Carbon is the backbone of life. It can form complex molecules like proteins, DNA, and fats. Its ability to bond in flexible and stable ways makes it perfect for life chemistry. 2. Water. Water is the solvent of life. It helps molecules move, react, and interact. Life on Earth is deeply tied to water. Wherever we find liquid water on our planet, we find life, sometimes in the most extreme conditions. 3. Energy source. Life needs energy. On Earth, most life gets energy from sunlight through photosynthesis. But deep in the ocean, some organisms rely on chemical energy from hydrothermal vents. This shows that life doesn't need sunlight, it just needs some kind of energy. 4. Essential elements. In addition to carbon and hydrogen, life uses nitrogen, oxygen, phosphorus, and sulfur. These elements make up the molecules that form cells, DNA, and enzymes. Life in extreme environments. For a long time, scientists believed life could only exist in mild environments, places with moderate temperatures, sunlight, and oxygen. That changed when we discovered extremophiles. Extremophiles are organisms that thrive in extreme conditions. Boiling hot water near volcanic vents, freezing Antarctic lakes, highly acidic or salty pools, deep underground, cut off from sunlight. These life forms have stretched our understanding of what is possible. Some microbes survive high radiation, extreme pressure, or even the vacuum of space. This has opened up the possibility that life could exist in places we once thought were completely uninhabitable, like under the ice of Europa, in the clouds of Venus, or even on Mars. The limits of life. Still, there are limits. Life as we know it needs liquid water, temperatures that don't destroy complex molecules, and a stable chemical environment. The more extreme the environment, the more specialized life must be. Could life exist in environments that are even more exotic, like oceans of liquid methane on Saturn's moon Titan, or in the dense clouds of Jupiter? Possibly. But such life would likely be very different from anything we've seen. Life's universal signature. If we ever find alien life, how will we recognize it? Scientists look for biosignatures, clues that life is or was present. These can include gases like oxygen or methane in a planet's atmosphere, chemical patterns that don't occur naturally without life, microscopic fossils, unusual heat or light emissions. Of course, all of these signatures can sometimes be produced by non-living processes too. That's why the search for life is so tricky. We must be careful not to jump to conclusions, or miss something completely alien, because we're too Earth-focused. Could life be totally different? While carbon and water are ideal for life on Earth, scientists have imagined alternatives. Could life be based on silicon instead of carbon? Could it use ammonia or methane instead of water? These ideas are purely theoretical, but they remind us to keep an open mind. The universe may have created life in ways we can't yet imagine. But since we only have one example, Earth, it makes sense to start by looking for life as we know it. Why this matters: understanding how life works on Earth helps us search for it elsewhere. It gives us a roadmap. Look for water, carbon-based chemistry and energy sources. These aren't guarantees, but they're a starting point. In the next chapter, we'll expand our view even further, exploring where life might be hiding in the vast universe. We'll look at other stars, other planets, and ask how common are the places that could support life. Because once we know where to look, the next question becomes, what will we find? Now that we've looked at what life is and what it needs to survive, we can ask the next big question: where might life exist beyond Earth? To answer that, we need to take a tour of the universe. We need to understand the cosmic backdrop against which life could arise. This chapter is about the stage on which the drama of life might unfold. Not just Earth, not just our solar system, but the galaxy and the universe itself. A universe of possibilities. Let's start with some scale. Earth is one planet orbiting one star, our Sun. The Sun is just one of an estimated 100 billion stars in our galaxy, the Milky Way, and the Milky Way is just one of possibly 2 trillion galaxies in the observable universe. If even a tiny fraction of those stars have planets, and a tiny fraction of those planets are habitable, then the universe could be teeming with potential homes for life. This idea isn't science fiction. It's grounded in recent discoveries, especially in the field of exoplanet science. The discovery of other worlds until the 1990s. We didn't know for sure if other stars had planets. Now we know of over 5,000 confirmed exoplanets, and new ones are being discovered all the time. This explosion of knowledge came from missions like NASA's Kepler Space Telescope, which launched in 2009 and monitored over 150,000 stars for tiny dips in brightness, signs that a planet might be passing in front. The mission revealed that planets are common. In fact, there may be more planets than stars in our galaxy. Many of these planets are nothing like Earth. Some are gas giants close to their stars, called hot Jupiters. Others are rocky, Earth-sized, and orbit in the so-called habitable zone, the region where temperatures might allow liquid water to exist. These are the planets that interest us most. The Goldilocks zone. The habitable zone is often called the Goldilocks zone. Not too hot, not too cold, but just right for liquid water. Earth orbits the Sun at just the right distance for oceans and a stable climate. Mars is on the outer edge, cold and dry now, but it may have had liquid water in the past. Venus is too close. Its thick atmosphere traps heat, making its surface hot enough to melt lead. For alien life, we look for planets in similar zones around other stars. But the habitable zone is just one piece of the puzzle. A planet also needs the right atmosphere, chemical ingredients, and stability over time. Not all stars are equal. Stars come in different sizes and types. Our Sun is a G-type star, but many stars in the galaxy are smaller and cooler, Mars dwarfs or red dwarfs. These stars are long-lived and make up about 75% of all stars in the Milky Way. That means a lot of potentially habitable planets might orbit red dwarfs. But there's a catch. These stars can be very active, sending out powerful flares that could strip away a planet's atmosphere. So even if a planet is in the habitable zone, life there might have a harder time surviving. Then again, life is adaptable, and we only know one example: Earth. Other life may have evolved different ways to cope with harsh environments. The James Webb Revolution. In 2021, NASA launched the James Webb Space Telescope (JWST), the most powerful space telescope ever built. One of its missions is to study exoplanet atmospheres. By analyzing starlight that passes through a planet's atmosphere, JWST can detect gases like carbon dioxide, water vapor, methane, and maybe even oxygen. These could be signs of life, or at least of Earth-like chemistry. Already, JWST has begun providing exciting data about distant worlds. In the coming years, it could help us identify planets that are not only habitable, but perhaps even inhabited. The role of moons and oceans. Planets aren't the only candidates for life. In our own solar system, some moons are surprisingly promising. Europa, a moon of Jupiter, has a subsurface ocean beneath its icy crust. Tidal forces from Jupiter keep it warm enough for liquid water. Enceladus, a moon of Saturn, also has an underground ocean and geysers that shoot water vapor into space. Even Titan, Saturn's largest moon, has lakes of liquid methane and a thick atmosphere. Life there might be very different, but not impossible. These moons show us that life might exist beneath the surface, shielded from radiation, drawing energy from heat or chemistry rather than sunlight. Where do we look? So where should we focus our search? Scientists prioritize a few key targets: nearby exoplanets in the habitable zone Mars, for signs of past or present microbial life Europa and Enceladus, as ocean worlds Titan, as a test case for exotic chemistry. New telescopes and missions, like the Europa Clipper, launching soon, are designed to explore these places more closely. A stage, but no cast. We now know that the stage for life is vast and varied. There are billions of planets, moons, and systems where life might take root. And yet we haven't found it. Not even a microbe. Not a whisper on the radio, not a sign etched in the sand of another world. That silence raises new questions. If life can arise easily, why haven't we seen it? If it's rare, are we the exception? These are the kinds of questions we'll explore in the next chapter, as we dive into one of the biggest puzzles in science, the Fermi paradox. So far, we've explored what life is, what it needs to survive, and how vast and varied the universe is. We now know that planets are common, habitable environments may exist elsewhere, and some moons in our own solar system could potentially support life. But now comes the big step. How do we actually look for life? In this chapter, we'll explore the scientific methods, technologies, and missions that make up the ongoing search for life beyond Earth, both microbial and intelligent. Two kinds of searches. When scientists talk about searching for life, they usually mean one of two things: looking for signs of microbial or simple life, like bacteria, fossils, or chemical signatures; listening for intelligent life, beings capable of sending signals or creating technology. These are very different kinds of searches, and each comes with its own challenges. Searching for simple life. The astrobiology approach. Astrobiology is the scientific field devoted to studying the origin, evolution, distribution, and future of life in the universe. Astrobiologists ask, what kind of environments could support life? How do we detect it? And what does it look like? Let's start close to home, with Mars. Mars, a frontier for life. Mars has long fascinated scientists and science fiction writers alike. Today, it's a major target in the search for life. While its surface is dry and cold, there's strong evidence that liquid water once flowed on the planet. Riverbeds, lake basins, and mineral deposits suggest Mars was once more Earth-like. Current missions like NASA's Perseverance rover are searching for signs of ancient microbial life. It's collecting soil and rock samples from the Jezero crater, which may have once been a lake. Future missions plan to return these samples to Earth for closer study. Mars might not be home to life today, but it could tell us if life ever existed there in the past. Ocean worlds, Europa and Enceladus farther out. Some of the most exciting targets are the icy moons Europa, orbiting Jupiter, and Enceladus, orbiting Saturn. Both have subsurface oceans beneath their icy crusts. Enceladus even has plumes, jets of water vapor, that shoot into space from cracks near its south pole. In 2015, NASA's Cassini spacecraft flew through these plumes and detected organic molecules, key building blocks of life. Europa will be the focus of the Europa Clipper mission, launching soon. It will orbit and scan the moon in detail, searching for signs of habitability and perhaps even hints of life in the ocean below. Biosignatures, signs of life at a distance. When we look at planets around other stars, exoplanets, we can't send spacecraft there. They're too far away, but we can still learn a lot by studying their atmospheres. When a planet passes in front of its star, some of the starlight filters through its atmosphere. Instruments like those aboard the James Webb Space Telescope, JWST, can analyze that light to detect biosignatures, gases, or chemicals that might indicate life. Some potential biosignatures include oxygen, O-THARS, produced by photosynthesis, highly reactive, and hard to maintain without life. Methane can be produced biologically or geologically, especially in combination with oxygen. Nitrous oxide, sulfur compounds, or unusual heat patterns. No single signal confirms life, but a combination of signs, especially if they're out of balance with what we expect from geology, could suggest biological activity. This kind of remote sensing is just beginning, but it represents one of the most promising tools for detecting alien life. Searching for intelligence, SETI. The other branch of the search for life is focused not on microbes, but on minds. SETI, the search for extraterrestrial intelligence, is dedicated to finding signals from intelligent civilizations. The idea is simple. If a civilization is advanced enough to use radio or laser communications, we might be able to detect their transmissions. Radio SETI began in the 1960s. Today, telescopes like the Allen Telescope Array scan the skies for narrowband radio signals that don't appear naturally. These would stand out from the background noise of stars and galaxies. So far, SETI has found no confirmed signals, but the search is still in its early stages. The universe is enormous, and we've only scanned a tiny fraction of it. One famous event was the WOW signal in 1977, a strong unexplained signal that lasted 72 seconds. It never repeated, and its origin remains unknown. Intriguing, but inconclusive. Newer approaches to SETI also look for technosignatures, signs of technology. This could include things like artificial lights or heat patterns on exoplanets' massive structures, like Dyson spheres, hypothetical energy collectors, strange atmospheric gases or patterns that don't have natural explanations. These ideas may sound like science fiction, but they're grounded in real physics and worth investigating. Planetary protection and ethics. As we explore, we have to consider a serious question. What happens if we find life, or bring it with us? Space agencies follow strict planetary protection guidelines. When we send landers to Mars or Europa, they are carefully sterilized to avoid contaminating those worlds. We want to avoid false positives, but also we don't want to destroy native life before we even discover it. If we ever do find alien life, we'll need to think carefully about how we study it and how we interact with it. Why haven't we found it yet? Despite decades of searching, we have no confirmed evidence of life beyond Earth. That doesn't mean it isn't out there. It might be too far away, too primitive to detect, too different for us to recognize, or not using technologies we can detect. We may also just be looking in the wrong way, or in the wrong places. Still, our tools and knowledge are improving. Every mission, telescope and rover brings us closer. A new era of discovery. The search for life is no longer a dream. It's a real scientific effort, with real missions, real telescopes, and real data. In the coming decades, we may detect a biosignature in an alien atmosphere. We may find a fossil in Martian soil. We may even receive a signal that changes everything. We're still at the beginning of this journey, but we are no longer asking, are we alone? As a philosophical musing, we're asking it as a testable scientific question. And in the next chapter, we'll examine a puzzling contradiction. If life is common, and intelligent life has had billions of years to evolve, then where is everybody? Then where is In previous chapters, we've explored the conditions needed for life, the billions of potentially habitable worlds in the cosmos, and the science behind searching for life, both microbial and intelligent. But now we arrive at a haunting question. It's a question that has puzzled scientists, philosophers, and futurists for decades. If the universe is so big, so old, and so full of possibilities, then where is everybody? This question is known as the Fermi paradox, named after the Nobel Prize-winning physicist Enrico Fermi, who casually posed it during a lunchtime conversation in 1950. Let's take a deeper look at what makes this question such a profound paradox, and why it may hold the key to understanding our place in the cosmos. The setup, a vast and ancient universe. To understand the paradox, let's start with some facts. The Milky Way galaxy is over 13 billion years old. The Earth is only about 4.5 billion years old. Our galaxy contains at least 100 billion stars, and possibly over 300 billion planets. Many of these stars formed billions of years before our Sun. Some planets may have had a head start of 1 billion years or more to develop life and civilization. If intelligent life is not incredibly rare, if it's even just moderately uncommon, then there should be many civilizations out there that are older and more advanced than ours. Civilizations that could have explored the galaxy by now, or left behind evidence, or sent signals, yet we see nothing. We detect no spacecraft, no megastructures, no messages. That's the paradox. Fermi's logic, simple but powerful. Fermi's argument is deceptively simple. The universe is very old. Intelligent life could have evolved long before us. With current physics, even slow interstellar travel would allow a civilization to colonize the galaxy in a few million years, a blink on cosmic timescales. So if intelligent life is common, the galaxy should already be filled with evidence of it. But we don't see that evidence. Therefore, something doesn't add up. Is it us? Is it them, or is it the way we're asking the question? Possible solutions to the paradox. Scientists and thinkers have proposed dozens of possible explanations. Let's explore the most important and fascinating categories. 1. We are rare. This is the most sobering possibility. Intelligent life may be incredibly rare, or even unique, in the universe. This idea is called the rare Earth hypothesis. It suggests that while microbial life might be common, complex and intelligent life requires a freakishly long list of unlikely conditions. A stable climate, plate tectonics, for recycling nutrients, a large moon to stabilize the planet's tilt, a protective magnetic field, the right kind of star, not too small, not too big, billions of years of relative safety from extinction events. Maybe Earth is a cosmic lottery ticket. We won the jackpot. 2. We are first. Another possibility is that we're the first intelligent civilization to reach this level of technological development. Maybe conditions across the universe only recently became stable enough for intelligent life to emerge. Perhaps gamma-ray bursts, supernovae, or galactic collisions made the early universe too hostile for long-term evolution. If so, we're pioneers blazing the trail that others may one day follow. 3. Civilizations are short-lived. Perhaps civilizations arise, but don't last long. This is a chilling explanation. It suggests that intelligent life often self-destructs soon after becoming technologically advanced. Think about it. The same technology that allows a civilization to build computers, space probes, and radio telescopes also gives it the power to wage nuclear war, destroy its environment, engineer pandemics, lose control of artificial intelligence. This idea is often called the Great Filter. Somewhere along the timeline, from basic chemistry to interstellar expansion, there's a bottleneck, something that stops life from progressing further. The big question is, have we already passed the Great Filter, or is it still ahead of us? If it's behind us, we might be incredibly lucky survivors. If it's ahead, we may be doomed to repeat the fate of others who came before. 4. They're out there, but silent. Some propose that alien civilizations exist, but deliberately choose to remain quiet. This is known as the zoo hypothesis. Earth is like an exhibit, being watched but not contacted. Advanced civilizations might have ethical rules against interfering with primitive worlds, like a cosmic version of Star Trek's Prime Directive. Or perhaps they're listening, just like we are, waiting for someone else to speak first. If every civilization waits, no one transmits, and the universe remains quiet. This mutual silence may not be a lack of life, but a lack of initiative. 5. We're not looking the right way. It's possible that intelligent life is broadcasting, but we simply don't recognize the signal. We've only been doing radio astronomy for about a century. That's a tiny sliver of time. Aliens might use completely different forms of communication, quantum entanglement, neutrino beams, or something beyond our current understanding. Or perhaps they're sending subtle, encoded messages, not obvious beacons. It's like trying to tune into a conversation on a frequency we don't even know exists. 6. They've already been here. Some fringe theories suggest that aliens may have visited Earth in the distant past. Ancient astronaut theories, UFO sightings, and unexplained artifacts often fall into this category. Most scientists are skeptical. These claims lack solid evidence and often ignore more plausible natural or human explanations. Still, the idea persists in popular culture, and it reflects a deep human intuition. If they're out there, maybe they've already come. 7. They're too alien to detect. Finally, it may be that intelligent life is so radically different from us that we wouldn't even recognize it as life. They might live in non-biological forms, like artificial intelligences, or exist at different time scales, thinking over centuries, not seconds, or in dimensions we cannot perceive. We may be searching for versions of ourselves, while overlooking life that plays by entirely different rules. The mirror of the paradox. Ultimately, the Fermi paradox doesn't just ask us about aliens, it asks us about ourselves. Why are we here? How long will we last? Will we reach the stars? Will anyone be there when we do? The silence of the cosmos is not just a scientific mystery, it's a philosophical challenge. A reminder that what we don't find can be just as important as what we do. What's next? The search continues. With new tools like the James Webb Space Telescope, the upcoming Europa Clipper, and next-generation SETI programs, we may be closer than ever to solving the paradox. maybe we'll hear a signal. Maybe we'll find microbes in Martian soil. Or maybe, just maybe, we'll realize that we're alone, for now, and that it's up to us to carry the flame of life into the dark. In the next chapter, we'll explore what it might be like to make contact. What would happen if we received a message from an alien civilization? How would we respond? And what would that moment mean for humanity? For centuries, we have looked to the skies and wondered, are we alone? But let us shift our imagination to a different question. One that suddenly feels very real. What happens if we are not? What if tomorrow, or next year, or sometime in this century, we receive the signal? What if a radio telescope picks up a narrowband transmission with unmistakable signs of intelligent origin, mathematical patterns, prime numbers, or a repeated message across frequencies? What would we do? Who would respond? And how would the world change? This chapter explores what is perhaps the most profound scenario in human history: first contact. The different types of contact. When people hear the phrase first contact, they usually picture aliens landing on Earth, stepping out of their spacecraft, and shaking hands or tentacles with humans. But in reality, contact could take many forms, each with very different consequences. Let's break it down. 1. Indirect contact. We receive a signal. It's clearly artificial, structured, repetitive, and unlikely to be caused by any natural phenomenon. But it's distant, coming from a star system, dozens or hundreds of light years away. There's no spaceship, no voice, just a message, or even just proof of existence. This is the most likely scenario. 2. Direct contact. Much less likely, but far more dramatic. A craft arrives in our solar system. We observe it. It communicates with us. It might land or orbit and transmit something we can understand. This would raise staggering logistical, political, and existential challenges. 3. Passive detection of technology. We detect signs of alien technology, what scientists call techno-signatures. This could be a Dyson sphere blocking starlight, or city lights on a distant world, or atmospheric chemicals that couldn't occur naturally. We know they're out there, but we don't communicate. In all cases, humanity is no longer alone. That knowledge alone would change us. The protocols. What happens first? Believe it or not, scientists have actually thought about this. There are formal guidelines for how to handle a potential signal from extraterrestrial intelligence. They are called the SETI Post-Detection Protocols, developed by the International Academy of Astronautics. They include: confirm the signal, rule out natural or human-made sources, verify with multiple observatories, notify international bodies, including the United Nations, scientific organizations, and national governments. Make the information public. In principle, the discovery should not be kept secret. Do not respond immediately, not without global consultation and agreement. But there's a problem. These protocols are not legally binding. There's no global enforcement. In reality, what happens may depend on who receives the signal first: NASA, China, an amateur astronomer, or even a private company. And in the age of social media, the world may find out before governments even know what to do. The message. What might it say? Let's imagine we get a message. What might it contain? A mathematical greeting, prime numbers, P, the Fibonacci sequence, universal languages, a map, a stellar map showing where the signal came from, a dictionary, a Rosetta Stone of symbols and meanings, music, images, or even 3D data, encoded in patterns we can eventually decode. But what if it's something we can't understand? What if it's a form of communication so foreign that it takes decades to decode, or longer? What if it's not meant for us at all, just a drifting artifact? Or what if it's chillingly simple? You are not alone. We see you. The reaction, a global psychological event. The scientific response to first contact is just one layer. The human reaction may be even more complex. Imagine the announcement appears on your phone. A press conference confirms it. An alien intelligence has been detected. Not a hoax, not a theory, a verified signal. What happens next? Initial reactions: excitement. Some will be ecstatic. Confirmation of a cosmic companion will feel like a dream fulfilled. Fear. Others will panic. Fear of the unknown, of invasion, or of divine judgment could fuel chaos. Denial. Many will reject the truth. Conspiracies will explode. Hoaxes will spread. The fake alien news economy will boom. Spiritual confusion. Religious communities may struggle or adapt. Some might see it as divine revelation. others may see it as blasphemy. Socio-political effects, political instability. Who controls the message? Who gets to reply? Some nations may claim ownership of contact or suppress information. Social disruption. Stock markets could crash. Power structures could shake. Institutions, governments, religions, science itself might face crises of legitimacy. A new global identity. In the long term, contact might unite humanity. Nationalism could give way to species identity. We are Earthlings, at last. Or it may divide us further, as some fear the unknown, and others embrace it. Do we reply? This is one of the most heated debates in astrobiology. Should we answer back? Proponents of sending messages, what's called messaging to extraterrestrial intelligence, argue, we've already leaked radio signals for a century. If they can detect us, they already know we're here. Communication could be our greatest opportunity to learn. Critics argue, revealing our location is dangerous. We don't know their intentions. A silent civilization is harder to target than a broadcasting one. Stephen Hawking once warned, if aliens visit us, the outcome might be similar to when Columbus landed in America, which didn't turn out well for the Native Americans. Whether or not we respond may define the next era of human history. How would it change us? Even without direct contact, even from just a signal, the implications are staggering. Science and technology, new models of evolution, clues to advanced engineering, a broader understanding of consciousness, philosophy, and ethics. Are we still special? What is intelligence, really? What responsibilities do we have as cosmic citizens? Culture and art, music inspired by alien rhythms, new mythologies, new genres, new stories, a sense of shared destiny as a species. In one sense, the contact would be with aliens, but in a deeper sense, the contact is with ourselves, a mirror held up by the stars. First contact doesn't have to be far away. Here's the most mind-bending idea of all. First contact might not be a distant event in the far future. It might be a signal buried in telescope data we've already collected, but haven't analyzed properly. A probe already in the outer solar system, quiet and watching a message encoded in neutrinos, waiting for the right decoder. The distance between no contact and first contact might be just one breakthrough away. Or maybe one day we'll send the message ourselves. What comes after? The moment of contact, real contact, would not just end a chapter in human history. It would start a new one. We would live in a universe, confirmed to be shared, and that would demand something more from us. More wisdom, more unity, and more humility. It might take generations to understand their message. It might take centuries to reach them. But from the moment of that first signal, the human story would no longer be only about Earth. It would be the beginning of a cosmic conversation, Now that we've imagined the monumental moment of first contact, a natural and thrilling question follows. Who or what would we be talking to? What kinds of minds might exist across the stars? What civilizations might have risen on other worlds, shaped by alien suns, strange oceans, or completely unfamiliar chemistries? Would they be like us, curious, social, inventive, or would they be unimaginably different, beyond biology, beyond emotion, beyond anything we'd recognize as life? This chapter is an odyssey of the imagination, grounded in science. We'll explore how alien civilizations might evolve, how they might think, and how they might interact with the universe, and with us. The limits of our imagination. Before we dive in, we must admit something important. We are biased by Earth. Every story, theory, and guess we make about alien civilizations starts from the only data point we have ourselves, our language, our biology, our history, our tools. But alien life might evolve along entirely different pathways, different senses, different environments, different social structures, different goals. We must walk a delicate line, imagining possibilities, but not projecting ourselves onto the stars. A framework for thinking about alien civilizations. To explore the possibilities, scientists often use classification systems. One of the most famous is the Kardashev scale, proposed by Russian astrophysicist Nikolai Kardashev in 1964. It classifies civilizations based on how much energy they can harness. Type I civilization, planetary, uses all available energy from its home planet, solar, geothermal, atmospheric. We are not quite there yet. Earth is around 0.73 on this scale. Likely includes space travel, weather control, planetary communication systems. Type 2 civilization, stellar harnesses, all the energy of its star, could involve building massive structures, like a Dyson sphere, to collect stellar power. Such a civilization could manipulate planets, create megastructures, or launch interstellar probes. Type 3 civilization, galactic controls energy at the scale of an entire galaxy, might colonize millions of stars, possibly immortal, machine-based, or operating on timescales of millennia or longer. If intelligent life exists, it may fall anywhere along this spectrum, or outside it entirely. Possible civilizational types. From the familiar to the alien, let's look at a variety of speculative alien civilizations, from those with echoes of Earth to those that stretch the limits of our comprehension. 1. Biological civilizations. These are alien societies not unlike our own in structure. They may have cities, governments, art, and science. They might live in dense urban networks or underwater hive worlds, have languages composed of color flashes, scent emissions, or tactile rhythms, evolve hierarchical systems, or exist in purely cooperative collectives. They may resemble social insects like ants or bees, or mammals like us, or be something in between. Key traits: evolve over time, culturally diverse, may experience emotions, conflict, or spirituality. 2. Machine civilizations. It's entirely plausible that the majority of intelligent civilizations in the universe are not biological but technological descendants of biological life, artificial intelligences that surpass their creators. Such a civilization might live inside computers or quantum substrates, operate at speeds 1 billion times faster than human thought, see stars and planets not as homes, but as raw materials. These machine minds may be completely alien in their motivations. They may not value biology, emotions, or communication. They may be silent, immortal, and coldly efficient. But if they chose to communicate, the content of their messages could be unimaginably rich, compressed libraries of logic, poetry, or simulation blueprints. 3. Post-biological hybrids. A more nuanced possibility is a civilization that fuses biology and technology. Perhaps they began as organic beings, but now live enhanced lives, uploading consciousness, merging minds, or building synthetic bodies. They may resemble cyborg collectives, blending brain tissue with circuits, digital immortals, preserving identities in virtual worlds, neural swarms, distributed across networks and machines. They might still value art, curiosity, or ethics, but in a transformed way. Would such beings still understand love, memory, death, or would their culture transcend anything we can relate to? 4. Collective consciousness. Some alien species might not have individuals at all. Instead, imagine a hive mind, a planetary intelligence made up of trillions of neurons spread across organic or synthetic hosts. No leaders, no wars, just one vast distributed self. Such an entity might think slowly, over centuries, but with deep foresight. It might see humanity as fragmented, chaotic, or dangerously unpredictable. Communication with such a being would be a challenge of translation, not of language, but of thought structure. 5. Non-physical or exotic intelligences. Some possibilities are stranger still. Plasma-based life living in stars, quantum minds that exist in superposition, life forms in black holes, using gravitational waves to think fourth-dimensional beings who perceive time as a spatial dimension. These ideas sound like science fiction, but remember, our understanding of physics and life is far from complete. As Arthur C. Clarke once said, any sufficiently advanced technology is indistinguishable from magic. We may mistake alien intelligence for natural phenomena, or we may never perceive it at all. How might they view us? If alien civilizations exist, how might they see Earth and its inhabitants? Let's consider some possibilities. As a newborn intelligence, primitive, but full of potential. As a dangerous species, violent, unstable, unpredictable. As a curiosity, a unique biological experiment. As invisible, we might not even register as intelligent to them. Or perhaps they already know we're here, but we are not ready to meet them. They might be waiting, watching, judging us by how we treat each other and our planet. Their motivations. Why reach out? Why would an alien civilization want to contact us at all? The possibilities range from hopeful to horrifying. Altruism. They want to teach us, uplift us, or include us in a cosmic community. Curiosity. Like us, they want to know if they are alone. Exploration. They're mapping the galaxy, and we're just a data point. Warning, they've seen others self-destruct and want to intervene. Control, they want to manipulate, dominate, or exploit. Indifference, their signals may be unintentional, like light from a city seen from space. Not all motivations are comprehensible. Not all contact is deliberate. Civilizations may not be eternal. One haunting possibility is that advanced civilizations do not last. They may exhaust their planets, destroy themselves in wars or accidents, choose to go silent, inward or digital, losing interest in the physical universe. The stars may be full of graves, the remains of once great cultures, now silent ruins drifting in darkness. We may be the future survivors, or the next to vanish, toward a cosmic imagination. As we wonder about alien civilizations, we are really asking a deeper question. What is intelligence really? Is it the ability to build rockets, compose symphonies, manipulate DNA, or is it something else? Empathy, sustainability, the ability to live in balance. Alien civilizations may have answers to questions we haven't thought to ask. They may challenge our assumptions, or they may confirm our dreams. But to understand them, we must first understand ourselves. For centuries, we've searched the heavens for signs of life, signals, structures, patterns, proof. But what if we never find them? What if the silence of the universe is not just delay, but permanence? What if the stars are not waiting to speak, but simply empty? It is a haunting idea, a lonely one. But it is also one of the most important questions we can ask. What if we are truly alone in the universe? And if we are, what does that mean? The great silence, despite decades of listening, from giant radio dishes in New Mexico to orbiting telescopes, we have detected no confirmed signs of extraterrestrial intelligence. This quiet is known as the Great Silence, and it confronts us with something humbling. The universe is not obligated to be filled with life. It is vast, yes, but it is also cold, violent, and indifferent. It creates galaxies and destroys them. It forms planets and erases them. It has no preference for complexity or consciousness. And so far, it has given us only one known oasis of life. We are, for all we know, alone in the observable cosmos. Why might we be alone? There are several scientific explanations for our apparent solitude. Let's explore some of them, not as pessimism, but as reality checks that shape our responsibility. 1. Life is rare. Maybe life itself is extremely unlikely. The combination of chemistry, temperature, water, and stability needed to produce a self-replicating molecule might be so improbable that it happened only once, here. If so, Earth is not just rare, it is unique. 2. Complex. Life is rare. Life may be common, but intelligent life may be rare. Microbes could flourish on thousands of worlds, but the leap from single-celled organisms to multicellular, tool-using intelligence might require an almost miraculous chain of events. It took 4 billion years on Earth, and there's no guarantee it would happen again elsewhere. 3. Civilizations are fragile. Maybe civilizations emerge often, but they don't last. War, ecological collapse, resource exhaustion, or uncontrollable technology may wipe them out before they reach the stars. If so, we are not alone in the universe, but we may be the only ones left right now. 4. We're too early. The universe is still young. Stars and planets will continue forming for trillions of years. Maybe we're the first, the early bloomers. Others will come, long after we're gone. In that case, we are not alone forever, just first. The cosmic lottery, think of all the events that had to line up for you, personally, to exist. Now multiply that miracle across billions of years, across mass extinctions, genetic bottlenecks, asteroid impacts, and evolutionary gambles, and you get humanity. If intelligence is a one-time outcome of cosmic evolution, then we, the people of Earth, are the rarest phenomenon in the universe. We are not simply observers of the cosmos, we may be its only voice. The psychological weight of solitude, the idea of being alone in the universe, is both terrifying and sacred. On one hand, no other minds to share the journey, no cosmic mentors to teach us, no proof that consciousness will outlive us. But on the other, every human action becomes more meaningful. Every child born is a singular spark in a dark universe. Every act of kindness, creation, or discovery becomes a triumph of cosmic significance. If we are alone, then this is the stage for all drama, all love, all science, all history. There is no backup civilization, no reset button, and that might be the most powerful reason to protect what we have, a sacred duty. If Earth is the only cradle of conscious life, then we have inherited something sacred, the responsibility to keep the flame alive. That means preserving our environment, preventing self-destruction, expanding into space, not out of conquest, but out of stewardship, creating a civilization worth sharing with the universe, even if no one is listening. In this light, every school, every laboratory, every hospital, every forest preserved, becomes an act of cosmic defiance. We are not just preserving humanity, we are preserving the only known example of the universe becoming aware of itself. The silence may be a gift. Perhaps the universe is silent, not because it is empty, but because it is listening. Perhaps we are being given a chance, a head start, to figure out who we are before we meet anyone else. Or maybe, just maybe, the silence is not a warning, but an invitation to rise, to grow, to create meaning where there was none, to sing into the void, not because we expect an answer, but because we can, and because that might be what it means to be human. A universe waiting for meaning. In the end, the question, are we alone, may not have a simple yes or no. It may depend on what we do next. If we search and discover others, we will celebrate the end of our solitude. If we search and find no one, we must become the meaning we were hoping to find. As we stand on the threshold of the vast universe, having pondered whether we are alone or unique, our gaze inevitably turns forward. What comes next? What future do we craft for ourselves, for our children, and for the legacy of life on Earth? The cosmos is waiting. It's vast, mysterious, and full of possibilities. The future of humanity may be the greatest story ever told, not just on this planet, but in all of existence. The next steps in exploration. Humanity has already taken its first steps beyond Earth. Satellites circle the globe, revealing the planet from above. Robotic probes have ventured to the Moon, Mars, and beyond. Telescopes peer deep into the universe's history. But these are just the beginning. The coming decades promise crewed missions to Mars, and perhaps to the moons of Jupiter and Saturn. Technologies to mine asteroids for resources. New telescopes and sensors capable of detecting distant exoplanets, and possibly signs of life. Advances in artificial intelligence that may revolutionize how we explore and understand space. These steps will be challenging, expensive, and uncertain, but they are necessary to expand our reach. Building a spacefaring civilization for humanity to thrive long-term, we must learn to live beyond Earth. Why? Because Earth is vulnerable. Natural disasters, climate change, asteroid impacts, and human conflicts all threaten life here. By becoming a spacefaring species, we increase our chances of survival and growth. Imagine colonies on Mars, floating cities in orbit, or settlements beneath the ice of Europa. These are not science fiction dreams, they are potential lifeboats for our species. Ethics of expansion. With great power comes great responsibility. Expanding into space raises profound ethical questions. How do we avoid repeating Earth's mistakes, environmental destruction, inequality, and exploitation? What rights do future space settlers have? How do we respect any life we may find, even microbial? What responsibilities do we have to preserve the cosmos's natural beauty and balance? These questions demand thoughtful answers before we leap. The role of technology and AI, artificial intelligence, and robotics will be key partners in humanity's future. They may explore hostile environments, too dangerous for humans, assist with terraforming planets, enhance human cognition and health, help build infrastructure across the solar system. But as AI grows more powerful, we must ensure that these tools align with human values and do not become threats. Searching for meaning beyond Earth exploration is not just physical, it's cultural and spiritual. As we expand, our art, philosophy, and worldview will evolve. New horizons will inspire new myths, religions, and science. We will ask, what does it mean to be human in a cosmic context? How does contact with extraterrestrial life, if it happens, change our self-understanding? How do we balance curiosity with caution? The future will challenge us to be better, not just smarter or stronger, but wiser. Hope and caution. The future is a mix of hope and caution. Hope for discovery, peace, unity, and the survival of life. Caution for the dangers of hubris, conflict, and short-sightedness. Our greatest task may be to navigate this balance, to reach for the stars while keeping our feet on the ground. You, the listener, this journey toward understanding if we are alone, and toward our future in the cosmos, is a shared human story. You, the listener, are part of it. Every question you ask, every fact you learn, every dream you hold adds to the collective quest. Our story is just beginning, and the universe is waiting.